everyone, I'm Tian. I'm a PhD candidate in civil engineering at the University of Bologna. The topic of my research is on the surface activation of end-of-life tire rubber using hydrogen peroxide to enhance its compatibility with bitumen. Our goal is to advance recycling methods that support pavement sustainability with high quality. And this study is actually part of the Green Nexus project, a Marie Curie network focused on sustainable society. In the past, the global annual production of waste tires has reached approximately 1 billion kilograms. Recycling this rubber into pavements presents an efficient solution. However, improving the compatibility with bitumen is crucial for successful application. Despite existing physical and chemical treatment methods, such as using hydrogen peroxide for a more environmentally friendly approach, research in asphalt applications remains limited, lacking systematic and molecular level analysis. So my study aims to combine laboratory testing with the molecular dynamic simulation. And this is the outline. We can talk in detail. For the laboratory experiments, various materials were utilized. Fenton's reagent on the right was for the activation. It includes deionized water, hydrogen peroxide, and some other chemical agents. Then, to assess the chemical and physical properties, we conducted tests including FTIR and SIIV, and boiling tests using rubber in coarse particles. Also, storage stability was performed with DSR and the softening point tests to indirectly verify the compatibility, and this was finished using rubber in fine particles. All of the rubber materials were from Glen Company. Besides, base bitumen and emulsified bitumen were used for storage stability tests and boiling tests, respectively. And we employed surface treatment with Fenton's reagent to activate the crumb rubber. And this picture shows the whole process with detailed conditions. Then we prepared the binder samples using fine activated rubber for stability testing. And the laboratory experiments encompassed a series of tests including micro and macro aspects. First, SIIV for texture analysis, contact angle measurements for surface energy assessment, and FTIR for chemical composition analysis. Then storage stability tests on the modified binders to assess the stability, and boiling tests on coarse rubber with emulsified bitumen after evaporation to examine the adhesion between rubber and bitumen. Then it's a result about the microscopic analysis. First is the SIIV. SIIV images showed a regular and clean surface for rubber with cleaning and a rough texture for activated ones. But for original rubber, obviously there are impurities on the surface. The contact angle and the surface energy measurements indicated that activated rubber has a smaller contact angle with emulsified bitumen and higher surface energy, especially the polar components. And this suggested enhanced adhesion potential to bitumen after the surface treatment. And FTIR focused on the changes in chemical bonding. We observed the breaking of single and double bonds in activated rubber, introducing more polar groups such as hydroxyl and carboxyl groups. These modifications contribute to the increased surface energy and compatibility with bitumen. And for the macroscopic test, softening points showed the difference between the top and the bottom layers of binders containing original rubber is greater than that of containing activated rubber. It means the stability of the former is worse. Indirectly verified the better compatibility between activated rubber with bitumen. And it also relieved an interesting phenomenon. The value of the bottom layer was higher for binders containing original rubber, which was opposite to the other group, because during the treatment process, a large amount of higher density carbon black is released, making the rubber more porous. This reduced the density of the rubber while increasing the proportion of elastic materials within it. And this can be also explained combining with the DSR results. According to the phase angle, binders with activated rubber exhibit greater elasticity and stability, with lower segregation rate calculated based on G star. Then we can get bitumen stripping rates from this formula. It shows that the value of activated rubber is the lowest one, indicating that better adhesion to bitumen. So we can see from the picture that after boiling, activated rubber still form the cohesive crumbs, while the cleaned rubber shows a moderate level of cohesion, and the original one exhibits weak adhesion with the highest stripping rate. And then, on the basis of the result of the previous experiments, we know about that the strong oxidation of hydrogen peroxide can lead to the breaking of double bonds, like this, and introduce some polar groups like hydroxyl groups and carboxyl groups. So we continue to perform simulation to verify. But actually, my work is still in the modeling phase. I've established some cell models for original rubber, shown on the left, and completed the whole process of optimization in terms of both geometric structures and energy. And I performed the same process with activated rubber, the base bitumen, and the hybrid cells with those two kinds of rubber and bitumen, like this. Besides, I established the layer models with rubber and bitumen with optimization process. Next steps, we plan to finish the simulation and the analysis. For the cell models, we can check if the activated rubber has closer solubility parameters and bigger binding energy with bitumen. Because it would mean it is more compatible with bitumen. Then we can analyze the diffusion performance combining layer models. In theory, the increased compatibility would lead to lower self and interdiffusion because the strong force between rubber and bitumen can impede molecular movement. In conclusion, our research combined the multi-scale tests and molecular dynamics to explore the effect of surface treatment using hydrogen peroxide. First, microtest reviews the physical and chemical differences of the surface between three kinds of rubber and showed the better properties of the activated one. Then, boiling and stability tests also verified that the activated rubber has lower stripping rate and higher stability with bitumen, which means the better compatibility. For the plan, the simulation and analysis of dynamics should be done, and we will design composite methods to improve the compatibility more efficiently. And finally, thank you for your attention and welcome to know about our green next project.